Okay, welcome to the part 2. So the curved surface area. So considering the cylinder, if you look at the shape, it looks as if there's a curved surface, then there is a covering and another one below. So we are dealing with that curved part. That curved part forms, let's say, if we go around it, is going around the surface of that cylinder. So it's like going around a circle. So once you go around the circle, it's like you are going around the circumference of the circle. That becomes 2 pi r. Then don't forget that the whole of the cylinder goes with the height, so 2 pi r and h. So that's just one way to remember the curved surface area. The curved part is the circumference relating with the height, so therefore the curved surface area is 2 pi r h. Now we move to the total surface area. So if you remember what I said earlier, I said the cylinder is made up of like a curved part forming a circle, then the covering of for those circle, the first covering and the second covering. But if we cover them, we already have another area. We have to find another area. First we have the curved surface area just for the curved part, but once we cover the cylinder, now we are having another area, another surface on it. That is the up one, the one up, the one down. So to get the total surface area, you need to get the curved surface, which is already the circumference relating to the height, that is 2 pi r, then h. Then for the total surface, you have to find the area of the remaining part. So we have two circles that cover the cylinder. So it's pi r square, that is area. So if you look at the formulas, you can find out that we have total surface area means the curved surface area plus the area of those two circles that cover the cylinder. So if you represent them accordingly, you'll see the formulas correlate. So you can factorize and represent them any way you prefer. But to me, I can use 2 pi r h, that's for the curved surface, plus pi r square, but that pi r square is doubled because we have one up, one down. But if you want to factorize, you can have 2 pi r into bracket h plus r, or 2 pi r into bracket r plus h. It does not matter, anyone that comes first. So that is it for now. Then we'll start solving and practicing some calculations. Alright, some bonus formula. So what if one part of the cylinder, I said both parts should be closed. So if one part is open, if you read this, it says the surface area, or the total surface area of an open top cylinder, like if one part is open. So if one part is open, instead of saying 2 pi r square, it's first the total surface area. When the cylinder is normal, that means both sides are closed, it is 2 pi r h. That is the curved surface area, 2 pi r h, in the sense that the curved surface is the circumference with the height plus 2 pi r square. We have one area of the surface that is closed, one above, one below. But in this case, if one part is open and it's in the question, just know that it can't be 2 pi r square, it will be pi r square. So it can either be represented as 2 pi r h plus pi r square, or pi r square will come first, then 2 pi r h. The major difference is that if one side is open, you are not going to see 2 pi r square. You can only calculate for one covering, that will be just pi r square. So that is it. Then we deal with. Alright, I won't beat about the bush for this one. So for the hollow cylinder, the one thing about hollow cylinders is that there is a cylinder inside a larger cylinder. So the one that is large takes the big arrow, you can see the diagram. The one that is small takes the small arrow, that is the one inside the larger cylinder. So how will you remember the formula? If you know the curved surface area, that is the CSA, and the total surface area represented in the factorized form 2 pi r h then 2 pi r square, but if it's factorized it is 2 pi r into bracket h plus r. So once you know that, what you do is that for hollow cylinders we are going to represent the radius. We cannot just have one radius. What are you talking about? We can't just have one radius. We have to have a small radius and a bigger radius because we have a cylinder inside a larger cylinder. So wherever I see radius, you can't take it like that. You have to represent them in that form. So for the curved surface area of a normal cylinder is just the curvedness, that is the circumference around it in respect to the height. I told you the curved part, we are not dealing with the upper area and the lower area, that is the covering made up of circles that is covering them. That will give us 2 pi r square, meaning pi r square, but we're having double circles, so it's 2 pi r square. But for the curved surface area, we're just going around it, that is the circumference around it. 2 pi r is the circumference, but the circumference goes all the way up, so with the height, so it is 2 pi r. Now for hollow cylinder, this is what you do. Since you know that the curved surface area is 2 pi r h, just take away that arrow. I don't want to see that small arrow there. Then you just put a bracket, because we can't just take it like just arrow. We can't represent arrow like that. For hollow cylinders we have two arrow. We have one large arrow and the other one. So therefore the curved surface area will change in the format whereby the small arrow will be removed, then you just add into bracket big arrow plus small arrow. That is all, the end of the story. Then for the total surface area, we have what they call it, 2 pi r then h plus r blah blah blah. So this is what you do. Here. You exclude the r also. So you are still going to put, we have 2 pi r. Just forget about the bracket h plus r. We don't care about the bracket. So once you want to convert that total surface area to the total surface area of a hollow cylinder, since it's 2 pi r then into bracket h plus r, ignore the bracket, then we are dealing with 2 pi r. So in the sense that the initial things that we will cancel out that arrow and represent it in bracket as big R plus small r, then we'll do it again plus another one for the second time, but in this case we are going to represent them as squared, as the difference of two squares, big R square minus R square. So that is just it. Let's go back again. The total surface area is 2 pi r then into bracket h plus r. Ignore the bracket because we know we have our major bracket, that is big R and small r. So we are left with 2 pi r. So for hollow cylinder we exclude the small r because we know we have larger and big R. That is the way I'm saying this, so you can easily remember. So therefore we have 2 pi and the small r. So exclude that small r. That is the one left. Then you fix in your big R plus small r in bracket. Then you write it again, but in this case, difference of two squares, big R square minus small r square. So that's all.